All right, what's up, folks? This is Mr. Myesis, and we are coming here straight from my classroom after school today. And we're going to look at permutations and combinations, some more ways to count number of possibilities, number of outcomes. So I was supposed to give a shout out to one of my students to see if he actually watched the video. So here's a shout out to Thomas to see if he watched the video, Thomas. If you watched the video, then tell me what number I'm saying right now. The number is pi, because that's my favorite number, pi. It's also very tasty. Anyway, let's get into this, permutations and combinations. So a permutation is a selection of people or objects that's arranged in a certain order. Whenever you see like first, second, third, or pitcher, catcher, first baseman, positions, arranging things on the shelf where you have to decide what's going to come first or second. Those are when, or that's when order matters. But if the order doesn't matter, if selection A, B, C is the same as C, B, A. Give you an example. I'm ordering a pizza, right? And it doesn't matter whether I order pepperoni and mushroom or mushroom and pepperoni, because both pepperoni and mushroom are going to go all over the pizza. So the order in which I order the toppings for my pizza isn't really going to matter, because they're all going to be on the pizza anyway. That is called a combination. And what happens in a combination is, I'm going to write these down. Let's see, A, B. Let's say I have ABC. I have choices ABC, right? So order of ABC is ABC, CBA, ACB, BCA, BAC, and CAB, right? These are the possibilities. But if all of these are the same, right, there's not 6, there's really just 1, right? All of these are really 1. So I would have to divide my thing by 6 of them, because I would really want 1. And so we talked about this in class about taking something and dividing, taking our number of ways and dividing it by the repeats. So I want you to think about, while we're going that we're really dividing by repeats. Okay, because if we divide the repeats out, then we're gonna eliminate those guys. So what we're doing is we're dividing the permutation by the number of repeats. Let's take a look. So we're going to go and identify the situation as a permutation or combination. From 12 basketball players playing some hoop, how many ways can the 5 starters, assuming every player can play any position, so they're all like the same height and they all play the same position, how many of them can be chosen? So really it doesn't matter if I pick, the way I pick the 5 guys, they're going to play any position. So 5 guys picked in any order doesn't matter. This is a combination, right? It doesn't matter what order I put them in. Where in this case, from 12 basketball players, how many ways can the 5 starters be chosen to play a point guard, a shooting guard, a small forward, a power forward, and a center? So if I pick one, the first person is going to be this one. The second person is going to be the shooting guard. Third person is going to be a small forward, and then so forth. So I have positions that I'm actually going to put them in. That's a permutation, right? Because 5 the same 5 players, it depends on what position they're in. So let's go and calculate these out. Let's do the permutation first, because the combination is basically the permutation divided by the number of possibilities there are. So from 12 basketball players, I'm going to have 5 spaces. 1, 2, 3, 4, 5. And for the first person, I can have 12 of them. For the second person, I could have 11 of them. Then I can have 10, then 9, then 8. Okay, so that is my permutation. 12, 11, 10, 9, 8. Okay, so how many is that? That is going to be 95,040. Ooh, that's a lot of ways. All right, 12 players. Well, what about the combination? Well, the combination, remember, I'm taking Now I'm going to take all of those ways, 12 times 11 times 10 times 9 times 8, and that's going to be 95,040. And I'm going to divide it by the repeats. Now the repeats happens from the 5 starters, right? A, B, C, D, E is the same as E, D, C, B, A. Well, how many ways are there to organize 5 different players? 5 different players can be organized 5, 4, 3, 2, 1. So I'm going to divide this whole thing by 5, 4, 3, 2, 1, which this coincidentally is 5 factorial, right? Because it's going to go 5, 4, 3, 2, 1. So I'm going to divide it by 5 factorial, and I do that in my calculator, and I get 792. The combination is always going to be less than the permutation, right? So there are some fancy formulas for combination and permutation, and the formulas come from this idea that I just went over about dividing and not dividing. So let's take a look. Notice here that we talked about. I talked to a couple students here that this looked like a factorial, but it's not a factorial, right? This is not a factorial because in order for this to be 12 factorial, it would have to go all the way down 8, 7, 6, 5, 4, 3, 2, 1, right? It have to go all the way down to 1, right? But this doesn't. It stops at 8, right? It stops here. So what I'm doing is I'm actually going to divide. I'm actually dividing out. I'm dividing out all this stuff, right? These guys cancel out all that whole thing. Which, if you notice this right here, what's that? 7. That's 7 factorial. And right here, that is 7 factorial. Right? So I would divide out 7 factorial. So I'm really doing 12 factorial divided by 7 factorial. Right? Because then it divides those out. And this right here, I'm doing the permutation. The permutation, which I got over there, 12 factorial divided by 7 factorial. And I'm dividing it by 5 factorial. Notice here 7. What is 7? What does 7 look like? Is 7 anything? Can we get 7 from here? Can we get 7? 12 minus 5. Well, 12 minus 5, that's 7. Where do we get 5 from? Oh, that's 5 starters. That's where we get this 5 from. So these can be put into some formulas. Let's take a look at that. Here are the 2 formulas for permutation and combination. So it's the number of things you have divided by the difference of that. And R is taken at a time. So we go back here. N is 12 and R is 5. So we got N and N minus R, which is 7. Here we've got N. Well, we've got basically the permutation, and then we're also dividing that permutation by the repeats. Wrong way. And the repeats is R, right? Another way to write combination is with this notation here. We've got a parentheses, N, R, parentheses. This is not a fraction. There's no line here. It's N. We often say this is N, choose R. Like I have 12, choose 5. 12. Oops, what did I do with that? I'm going to say 12. I'm going to have 12 things, and I'm going to choose 5 of them. Okay, that's how you say that. All right, so let's go and take a look at some problems. I know this is taking a little while, but I want to make sure you really understood how my way here, my examples here, is, it just makes sense going into the formulas. Do we always have to use the formulas? No. Really what I'm concerned about, at least in my class, is that you understand what we're dividing out, whether or not it's a combination and permutation, and then we're actually going to let the calculator do the work for us. So let me do the next one, and then you'll see where the calculator, what the calculator does. So from 5 people in a club, how many ways can 3 be chosen as president, vice president, secretary? That one is a permutation. Why is it a permutation? Because we have positions. Now, if we're just forming a committee, that's a combination, right? All right, so let's identify these things as N. So we have 5 people. All right, so that's N. We want a committee of 3. That's R. All right, so we're doing 5 choose 3. And we write that as 5 factorial over 5 minus 3, which is 2 factorial times 3 factorial. Again, I'm just using the formulas. This one's 5 factorial divided by 2 factorial. And let's put this in the calculator. The calculator's kind of nifty, guys. Watch, I'll show you what happens here. So we want a permutation. Check this out. Menu probability permutations. N was 5, comma, R was 2, and we get 20. All right, so here we get 20. What's the combination? We'll go to our calculator. Menu probability combinations. N was 5. 5, choose 3. Right, because we're doing the other one. We're choosing, oh, I did choose 2 when I should have done choose 3. Oops. Let's go. We'll go back and do that over again. I know some of you are saying, "Oh, Mr. Rice, you messed up again." So sue me. Don't really sue me. All right, let's go back. It should be NPR 5, 3, 60. All right, so we should have 60 right here. You know, if we wanted to, you can also do in the calculator. You notice that there was a factorial, probability factorial, divided by 2 factorial would be 60. Okay, so I wrote down this part right. I just didn't put it in the calculator correctly. All right, so here's what you want to be able to do. All right, let's take a look at another one here. Go ahead and practice this one. See what you got. See what you got. Did you get this? All right, hopefully. All right, so the last thing I'm going to go over very quickly. Remember that, if we have repetition, what are we going to do with that repetition? We're always going to divide them out, right? We're going to divide out the repeats. So the way we divide out the repeats is we do our normal permutation, and whatever the repeats are, we're going to divide them out. All right? So if we have multiple repeats, then we're going to need to, take care of multiple of them. All right, so let's take a look. Identify this as a permutation or combination. How many different ways can the letters of word banana be arranged? Being arranged is a permutation. But we got a problem here. This has repetition. I can't spell, sorry. This has repetition because we've got an A and an A. If I took this one and then I lined it up with this one, that's the same if I took this one and lined it up with this one, right? So what we got to do is, let's see how many letters we have. We have 1, 2, 3, 4, 5, 6. So we're going to use 6 factorial divided by, let's see any repeats that we have. We have an A repeat. How many A's do we have? We have 1, 2, 3. So we're going to divide out 3 of those, 3 factorial. We have N repeats twice. So we're also going to divide out 2 factorial. And then we're going to go ahead and do that in our calculator. Okay. Any calculator will do. I have a TI Inspire. So I've got 6. Let me use a little fraction here. I've got 6 factorial divided by 3 factorial times 2 factorial. And that gives me, I got to move this to the side here, that gives me 60. All right? 60 ways. So remember, when we have repeats, we just want to get rid of them. We want to get them out because we don't want to repeat things. If we're using a combination, if we have a permutation with repeats, we want to get rid of them. And to get rid of repeats in these, we're going to divide them out. Okay? That's all I got for you today. We will talk to you soon.